Good morning, year sevens. Welcome to another chemistry session. We have a few tips for you while you work at home. Try to work in a quiet area with little distractions. Read all slides and questions carefully. Remember that if you get stuck, help is here. Teachers will be available between 9 a.m. and 3 p.m. And always remember, homework will need to be completed and posted by the deadlines. Driving question. The question that you should be able to answer by the end of today's lesson is, what is filtration? Now, your remember task. What do all these have in common? Now, if you don't know all of the pictures or items in the pictures, please grab someone in your house gently. Ask your mom or your dad, what are some of these objects and what are they used for? Pause the video and give yourselves 5 minutes to attempt this question. Again, the question that you should be answering, what do all of these have in common? Go. Welcome back. Let's see if you had done correctly. Now, as you should already figure out, it's filtration. That's what they all have in common. Now, they all rely on filtration. Now, filtration or filtering is a separation technique. You will learn other separation techniques over the next few lessons, including evaporation, distillation, and chromatography. Filtering in animals. Now, before I mentioned that filtering is a separating technique. Now, this technique is not only used in the lab, but as you can see, it is also used in the wild or in nature. The flamingos are part of a subgroup of animals called filter feeders. They feed by sieving food from water using specialized features or structures. The baleen whales, oysters, and some species of sharks, fish, and ducks are a part of this group as well. Now, everyday filtering. We do use filtering in one aspect of our lives or another. Filtering can be done while driving a car, by cleaning your carpets, or by even washing a load of dirty clothes. Now, there are filters in cars, vacuums, and tumble dryers too. But a question for you, what do you think they might be made of? And what do you think they might be filtering out? Now, you can pause the video, ask yourself these questions. Ask your mothers or your fathers these two questions. So, we're looking at filters in cars, vacuums, and tumble dryers. What do you think they're made of? And what do you think they might be filtering out? Pause the video and have a go. Welcome back. Now, filtering. Cars have hair and oil filters. They help to filter out any impurities. Vacuums have filters to trap dust. Tumble dryers have filters to capture threads and hair. So again, these are the answers to the questions before. So again, we're looking at filtering. Cars have air and oil filters. They help to filter out any impurities. Vacuums have filters to trap the dust. Tumble dryers have filters to capture threads and hair. Now, there are a few keywords that you must know by the end of the lesson. These keywords are highlighted. Words such as filter, filtrate, residue, and filtration itself. Now let's read. The material being used is called the filter. The substance that can be moved through the filter is called the filtrate. Let's read that again. The substance that can move through the filter is called the filtrate. Perfect. The substance that is left behind in the filter is called the residue. Again, the substance that is left behind in the filter is called the residue. This process is called filtration. Now, there's a little challenge for you here. Can you draw and label the apparatus using these keywords? Now, you can pause the video, go on Google, open different tab, go on Google, try to look at filtration. Try to find a diagram and try to label all of these. If you're finished with it, you can take a picture and send it in via email to my email address. Now, if you had given it a try, this is what you should have. Now, the title of your diagram should be filtration. Now, we need to label the diagram carefully. Now, as you can see, the mixture inside the beaker, we have a beaker. The beaker is this container that we have the mixture in. Now, we have a mixture. This mixture is made up of liquid and insoluble solids. Now, liquid in science might be, in most cases, water, and an insoluble solid such as sand. Now, this is a simple filtration activity that you can be asked in future quizzes and tests to come. Now, once you have the mixture of sand and water, you pour it into the filter funnel. Now, in science, we line the filter funnel with what we call filter paper, which helps to keep the sand behind. Now, once we pour the mixture of sand and water into the filter funnel with the filter paper, the water drips through, right? And the water is called the filtrate. So again, the filtered liquid is called the filtrate, and it's the water that comes from the mixture. Now, once all the solution or mixture is poured into your filter funnel and your filter paper, and the water has passed through it, what we have remaining, the sand, is called the residue. So again, let's go quite slowly again. Now, we have a beaker. This beaker contains a mixture of sand and water. The water is the liquid and the sand is the insoluble solid. Now we have filter funnel and filter paper. Now the filter paper is to stop the sand from going through, and even though it's a paper, it will allow the water to go through and not tear. Now we line the filter funnel with the filter paper. So as we pour the mixture of sand and water into a filter paper and filter funnel, the water will eventually seep through. Now this water has a specific name that we call filtrate, right? Once the water has filtered through the filter paper, what we have remaining is the solid bit, which is insoluble, the bit which wasn't dissolved in the water. All right, and this is called the residue. Now you might need to take a minute or two, pause the video, try to memorize different parts of this diagram. Now, filtration. Now, there are a lot of people around the world, a lot of countries around the world that don't have clean water to use. So they have to come up with a different method or different ways of cleaning the water to drink. Now, we're going to look at filtration intervention. Statistics from WaterAid. There are 844 million people in the world who do not have clean water. At current rates of progress, everyone in low and middle income countries won't have clean water until 2039. Around 289,000 children under 5 die every year from disease caused by poor water and sanitation. That's almost 800 children per day, or one child every 2 minutes. Wow. Again, around 289,000 children under 5 have died every year from diseases caused by poor water and sanitation. That's almost 800 children per day, or one child every 2 minutes. Wow. Now, water from lakes and rivers is often contaminated and is not safe for drinking. Now, what do you mean by contaminated? Now, the waters in streams, in most cases, if they run through a village, it will not be clean. So let's say that you are living in a village that is downstream from another village that's upstream that has access to the same water. Now, if there are farms nearby, now we have what we call leaching. So they might be, the crops might be planted near the river. The farmer goes and spray the plants with chemicals and pesticides. That chemical gets into the river, which contaminates the river. The river is no longer clean or safe to drink. Now, in the same scenario, the farmer might have animals. They might have pigs. They might have goats. They might have sheep. They might have cows. Use your imaginations. They might have dogs that go for a swim. Who knows? Those animals go to the lake or to the river to have a drink or to have a bath. Now, just imagine you're at the bottom of the stream. Will that water be clean or pure for you to drink? Would you drink that water? No. The water may contain grass, dirt, rocks, and other objects that can be easily seen. However, it often also contains bacteria and other microscopic organisms that cannot be seen easily. Your aim is to design an affordable way of filtering water. Now, this is a challenge that I'm going to give for you guys. Just imagine that you were in this scenario, all right? You live in an area where two towns have access to a stream or a river. You live at the second village down or town down. You know that your water is not clean. Now, your aim is to design a water filter and present it as a sale pitch. Now, things you must include. Now, this is very optional for you to do, but if you want to have a little fun with this, you can do it. So, you're going to create an invention that purifies water. You can draw it however you want to. This is your invention. Draw it, color it, label it, give it its name, make it catchy, make it something that your friends would want to buy to purify their water. The criteria must include at least two cheap filtering materials. So you need two materials that are very cheap that can be used for filtering. You should explain how your design works using scientific keywords. Remember the keywords that we are looking at before: filtrate, filtration, residue. You get that? All right. Use persuasive language and statistics. Try to convince your peers into buying your device. And who knows, if you do a very good job in the future, you might be able to use this pitch and to start your own business. Have a go. You can pause the video, have a go at it. Once you're finished, take a picture of it, send it in. All right. Now, remember, this is optional for you to do. Now, let's look at this. Let's say that we have this mixture of sand and water. How would we separate the mixture? Now, in chemistry, a mixture is a material made up of two or more different substances which are physically combined. A mixture is a physical combination of two or more substances in which the identities of the retained and are mixed in forms of solutions, suspensions, and colloids. Now remember, in a mixture, the substances or particles used, they are mixed but are not chemically combined with each other. It simply means that they can be separated into their different components. Now what we have here is sand and water. And of course, we know sand is insoluble and it will not dissolve. Now, in this case, we have a solute. Remember the terms that we use, the S's: solute, solvent, solubility. Those words, yeah? Now we're going to use a few of them. Now, what we have here is sand and water again. Now, we have the solute, which in our case is insoluble, which means that it is incapable of dissolving in a solvent. Now, the sand is, as we already know, cannot be dissolved. So in this case, it will be our solute. Now, the liquid. What's the scientific name given to the liquid? It is called a solvent. A solvent is a substance that dissolves a solute, resulting in a solution. A solvent is usually a liquid, but can also be solid or a gas. All right. Now, in this case, would this be a solution or just a mere mixture? Can you have a guess? Would this be a mixture or a solution? Definitely, I can hear you guys thinking it. This is definitely a mixture. Why isn't it a solution? Because the sand is insoluble. It did not dissolve. So it remains as a mixture. All right. Awesome. Now, there are a few key apparatus that we use when we're filtering. The first one we have on our screen is a beaker. All right. Now, you guys should remember this from term one when we looked at different materials or apparatuses that we use in the lab. All right. So I gave it a first one. Second one is a funnel. Do you remember what a funnel looks like? Sorry. This is a funnel. The third one, this is called a filter paper. Now, what we do when we're carrying out this experiment, we fold the filter paper into a cone shape. Now, why do you think we need to fold the filter paper into a cone shape? Why? We have to fold the filter paper into a cone shape for it to fit into the filter funnel. Now, as you can see, the shape of the filter paper and the funnel are the same. So the filter paper will fit easily and comfortably into the filter funnel, as you can see in this picture. So we put the filter funnel into a beaker. Now, in some cases, you can just rest the filter funnel onto the beaker itself, or in this case, you can use a retard stand and clamp to actually hold the filter funnel above the beaker. What would happen? Now, so let's say that you have poured your mixture, sand, and water into your filter funnel, which contains a filter paper. What's going to happen? Of course, the water is going to seep through the filter paper. The water will go down the filter funnel, and in this case, will go into the measuring cylinder. Now remember, the liquid is called the filtrate. What remains in the filter funnel and the filter paper is called the residue. Now, key terms that you must remember. Now, the residue is whatever remains after something else has been removed, while filtrate is the liquid or solution that has passed through the filter. Again, The residue is whatever remains after something else has been removed, while filtrate is the liquid or solution that has passed through a filter. Now, this is what the diagram looks like. So again, we have the liquid and insoluble solid. Why is it an insoluble solid? Because it cannot dissolve in water. We pour the mixture into our filter funnel and filter paper. What is the main function of the filter paper and filter funnel? It is to keep the sand or the residue behind while allowing the water or filtrate to pass through. Now, these are a few parts that you guys would need for the next activity. You must remember the liquid, a solid, filter funnel, filter paper, conical flask, residue, filtrate. Again, liquid, solid, filter funnel, filter paper, conical flask, residue, and filtrate. We're going to need these for the next activity. Now, your job right now is to use the words before and try to figure out the diagram. Now, what I'm going to ask you to do is to try to draw the diagram. Doesn't have to look exactly like this, but draw the diagram, take a minute or two, try to label them. Now, as you can see, they give you the first letter of each word that we need to use. All right. Now, this bit, we use sand and water, right? So I literally just gave you the S word. So the S is going to be sand or solid. And what is the name of the solid that remains in the filter paper? It is the residue. So the solid or sand, and this is called the residue. Now I gave it a first one. What I am going to ask you to do is to go ahead, draw the diagram, and label it. The paper inside the filter funnel is the dash dash. This paper is found in the dash dash. What is the name of the glass material or object that we use to catch the liquid? It is called a dash dash. The name of this blue thing here is a dash and it's also called a dash. Now take a minute and draw the diagram. Remember, it doesn't have to be drawn to scale. Once that is completed, take a picture and send it into my email. Now, that's it for today's lesson. I hope you enjoyed it and learned something new. Now that you're finished, I want you to go over to Google Classroom and complete the quiz. Until next time, keep safe.